Hi, this is Hunter's reassessment on forces in circular motion. In this, I'm reconstructing the question we had for the standard. I'm going to add a little twist to it, and I'm going to go around the circle instead of just doing points A and C. I'm gonna do all the points, create all the formulas, and see where it leads us, and try to see if we can make sure we got everything working correctly. First, what I did was I looked at point A, got the formula for it, and it's all in the y direction. It's all pointing downward. Then I went to point C, which was the tension was pointing inward, the acceleration was pointing inward in the x direction. In the y direction, it was just straight up pointing down. Likewise, in A, it was all pointing down in the y direction. Then I switched over to the G portion of the circle. And again, there was two portions. There was the x direction and the y direction. So I created the formulas for those directions. Then I went to B and created one at a 45-degree angle. So then I have mass times acceleration equals negative force of tension times cosine 45 degrees. And in the y direction, it's mass times acceleration in the y direction. So it's negative force of tension sine of 45 minus mg. So I went ahead and created these formulas. Let me go ahead and stabilize for you for a second so you can see. Then, after I went ahead and took care of that portion, then went ahead and went to go and solve these formulas. So let me zoom out a little bit. Alright, so I went ahead and got the mass, got the radius, the velocity. And the first part of the question was to find the tension. The second part was to find the acceleration on the objects if we had a constant tension. So on the first one, went ahead and drew a free body diagram of the force of tension, the force of gravity, well, mass times gravity, mg. And went ahead and solved the problem. Then, likewise, went to the bottom of the circle for E, drew a free body diagram for that, and mass times acceleration is equal to force of tension minus mg in the x direction. And in the y direction, again, all that was in the y direction. There was nothing in the x direction. So I was able to solve for the acceleration directly in the y direction. Now, went ahead and went to the C part of the circle, which is set at 0 degrees. And mx is equal to negative force of tension, and may is negative mg. Because on this part of the circle, there's only x and only y directions. Likewise, I also did that with the G portion of the circle. Here's where the little twist comes in. So we went ahead and created some more portions at 45-degree angles from the axes. And on that one we had to create some new formulas. So on the first one it was max is equal to negative force of tension cosine 45. And likewise in the y direction it was may is equal to negative f force of tension sine 45 minus mg. Divide out the mass on both of those items and we get the x hat and y hat components. Let me go ahead and list them so we can get a correct answer on those items. And we went ahead And we drew some more free body diagrams for the other positions. We got D, F, and H of the positions. We went ahead and created the axes and our standard XY axis. We went ahead and created our formulas. They're all pretty much the same. It's fairly repetitive, but we do get a different calculation on our X hat and Y hat components of our theory. And that's it. Thank you.